Alright, this is section 12.6, surface area and volume of spheres, starting on page 884. Number 1, find the surface area of each sphere or hemisphere. Round to the nearest tenth. So our formula for surface area of a sphere is 4 pi r squared, where r is the radius of a great circle. Basically think of a great circle as a cross-section of the sphere directly through the middle. So if you're able to cut the sphere into two hemispheres, or think of the equator of Earth, that would be the great circle. So in this case our radius is 9, so our surface area is equal to 4 times pi times 9 squared. So 4 times pi times 9 squared on your calculator, and rounded to the nearest tenth is approximately 1017.9, and since it's surface area, this would be square units, so square meters. And number 3, we want to find the surface area of our sphere, where the area of the great circle is 36 pi square yards. So, area of a circle is equal to pi r squared, and in this case it is 36 pi. So that's the area of our great circle. Surface area of a sphere is equal to 4 times pi r squared. Well, pi r squared is the area of the great circle. So we can substitute 36 pi in for pi r squared. So our surface area here becomes 4 times 36 pi, and 4 times 36 pi is approximately 452.4 square yards. For number 5, now we want to find the volume of the sphere or hemisphere. So the volume of a sphere with a radius of 10 feet. So our formula for volume of a sphere is 4/3 pi r cubed. So in this case our volume is equal to 4/3 times pi times 10 cubed. So we can just type that in as 4 divided by 3 times pi times 10 to the third power. And in this case we get approximately 4,188.8, and since it's volume, our units will be cubic units, so cubic feet. For number 7, we want to find the volume of a hemisphere, or the volume of half of a sphere with a circumference of the great circle as 24 pi. So if circumference is equal to 2 pi r, and in this case our circumference is 24 pi, and we need to know what the radius is, then we need to solve this equation, or this formula for r. So we're going to divide both sides by 2 pi, and pi cancels out, 2 cancels out, and 2 goes into 24 12 times. So our radius is 12, and we can substitute that into our formula for volume, which is 4/3 pi r cubed. Now this will give us the volume of the entire sphere, so we want to divide this by 2 to get the volume of the hemisphere. So 4 divided by 3 times pi times 12 raised to the third power divided by 2 would give us approximately 3,619.1 cubic meters. Number 9, basketballs used in professional games must have a circumference of 29.5 inches. What is the surface area of a basketball used in a professional game? So our circumference, which is 2 pi r, in this case is 29.5 or 29.5. So we need to solve for our radius by dividing by 2 pi. So our circumference is 29.5, which makes our radius 29.5 divided by 2 pi. Now we need to go further and find the surface area. So our surface area is given by the formula 4 times pi r squared. In this case, that would be 4 times pi times our radius, which is 29.5, divided by the quantity 2 pi, and then the entire radius squared. And this gives us approximately 277.0 square inches. On number 13, we need to find the surface area of the hemisphere. So the surface area of a hemisphere would be half of the surface area of the sphere, but then we have also this face that we have to consider. So where the sphere is cut, it makes a circular cross section that we need to add to the surface area of half of the sphere. So since surface area of a whole sphere is 4 pi r squared, our surface area is going to be half of that, or divided by 2, plus the surface area of the great circle. So the area of a circle is pi r squared. So if we simplify all of this, 4 pi r squared divided by 2, or 4 divided by 2, is 2 pi r squared. And then plus pi r squared gives us 3 pi r squared. And this is the surface area that we'll use for a hemisphere. So all we need to know is, what is our radius? Well, our diameter is 17, so divide that by 2, which gives us 8.5. So if we substitute that in, our surface area is equal to 3 times pi times 8.5 squared which gives us approximately 680.9 square inches. Number 15, find the surface area of a sphere where the area of the great circle is approximately 32 square feet. So area of the great circle, which is pi r squared, is approximately 32 square feet. Surface area of the sphere is 4 pi r squared. So pi r squared here. So we can substitute 32 in 4 pi r squared, and our surface area becomes 4 times 32, or 128, square feet. Number 17. Surface area of a hemisphere where the circumference of the great circle is 15 pi. So, surface area of a hemisphere would be half of the surface area of a sphere, which is 4 pi r squared, plus the surface area of a circle, because we have the spherical part, plus we have the cross-section part. So the area of the circle is pi r squared, and we simplify this. Half of 4 is 2, so we have 2 pi r squared plus pi r squared, so we get 3 pi r squared when we simplify. So the circumference, we are told, is 15 pi, where circumference is 2 pi r. So if we solve this for radius, divide by 2 pi, and half of 15 would be 7.5, which is our radius. So if we substitute this in, our surface area of the hemisphere is 3 times pi times 7.5 squared, which is approximately 530.1 square millimeters. Number 19, find the volume of the sphere. So, the diameter of the great circle is 2 centimeters. The radius is half of that, or 1 centimeter. Formula for volume of a sphere is 4/3 pi r cubed. So, we get 4 divided by 3 times pi times 1 to the third power. 1 times 1 times 1 is 1. So that pretty much goes away, and we just have 4 divided by 3 times pi, which is approximately 4.2. And don't forget, your units are cubic. So the volume of half of a sphere, so a hemisphere, is 4/3 pi r cubed divided by 2. So in this case, if the diameter of the great circle is 21.8, half of that would be 10.9. So if we substitute this in, we get 4 divided by 3 times pi times 10.9 to the third power divided by 2, which is approximately 2,712.3 cubic centimeters. So the volume of our sphere, which is 4/3 pi r cubed, where the circumference of the great circle, so circumference, which is 2 pi r, is 22. Therefore, the radius, we divide by 2 pi, 2 goes into 22 11 times, so our radius is just 11 over pi. If we substitute this in, we have 4 divided by 3 times pi times 11 divided by pi to the third power.